Hello, and welcome to this vSuite version 0.4 video tutorial. And in this video tutorial, I'm going to talk about three new nodes, or at least three nodes that I've written into a state that I can consider them to be sort of publicly talked about and publicly available. And these three nodes deal with the generation and manipulation of Radiance Images via the LiVi component of the vSuite. So you could generate Radiance Images before if doing a glare analysis, or if doing a Radiance preview, you could have saved the Radiance preview out to an image. But these new nodes are sort of image specific, and they will replace some functionality in the future, which are currently embedded within the LiVi simulation node. So if I just come into my vSuite node tree, I've got my standard LiVi setup, my LiVi geometry, my LiVi context, and my VI location node. Now, normally this geometry node and this context node would come into a LiVi simulation node, which has options for photon mapping and accuracy, etc. And we can preview the Radiance scene from that node. Just redo my exposure because this is an external scene. And once this has stopped, I could have pressed W down here and I could have written out a file name and I could have saved this image. But now we've got these new image nodes, and they are in the image nodes menu. And there's LiVi image, LiVi FC or false color image, and LiVi glare image. Now I'm just going to create a LiVi image first. Now the LiVi image node is quite similar to the LiVi simulation node in that it has a geometry in and it has a context in. But for this node, we now have to select a blender camera. We have, for the image generation, we have to have a viewpoint. So I've got one camera in my scene. I'm just going to pick that one. And if I just come out and come into my 3D view, I can just look at the scene from the camera perspective. Yeah, it's focused on this building pretty much. So once I've connected this LiVi image node up to my geometry and context nodes, then I can do a preview here in exactly the same way that I could do a preview just now from here. But the interesting bit is these new options down here, which are for generating an image. Now, the options up here, we could have a base name for the image that we're going to generate, but I'm just going to leave that blank, and that will just default. This flag here, illuminance, that says whether we are going to generate an image based on the amount of brightness or light coming out of the scene towards us, towards the camera, or the amount of light which is landing on the objects within the scene. So if I turn on illuminance, that's useful for potential later lux analysis. If I turn off illuminance, then that's simply a representation of the scene and the brightness coming off the scene. So any materiality or textures that you set will show up if this is off. If this is on, we will just get a sort of default scene. We can turn on fisheye, and I'll talk a little bit more about fisheye in a minute. We've got the usual accuracy, low, medium, custom, same as up here. And we have the photon map options as well, same as up here. So I'm going to just turn off that, leave everything else as it is. I can now set the resolution of the image that I'm going to generate. Now I want to keep things quick for this video tutorial, so I'm going to have a low resolution, 600 by 300. And because I've got a multi-core machine, I'm going to turn on multi-threading. Now this multi-threading option should only appear if you're on OS X or Linux, and it will only work if you're on OS X or Linux, because the methodology I use here to split the image up so that different processors can deal with the different portions of the image doesn't work on Windows. So I've got a 16 processor machine, so I'm going to hit 16 in the processors. And processes is a number of subdivisions of the image, number of pieces of the image I'm going to render. And then each processor will handle each part of the image. So you could argue this should at least be 16, or at least the same as the number of processors I have. But sometimes it's useful to have a multiple of 16, 32 or 48. I'm actually going to go with 80. The more pieces we break the image up into, the less likely it is we've got a single processor working on a portion of the image which is much more complex than the other portions of the image. And that processor then is just working alone. And it might slow down the final creation of the image. If we have a high number here, the image is broken down into smaller bits. So it's less likely that a single processor will be stuck working on a more complex part of the scene, because each part has been broken down into smaller pieces. But Radiance then has to keep, or the vSuite has to keep starting new processes. So this, if it goes too high, this might start to slow things down as well. So there's a balance between low numbers, chance of a core or processor getting stuck working on a more complex part of the scene, and higher numbers, there's some overhead in starting up new processes to deal with each part of the image. And with experimentation, you might find that perfect number. I tend to stick to sort of 4 times the number of processors, 5 times the number of processors, that kind of number. So if I now press image, a Kiwi window will come up and it will give us an indication of how long it's going to take to complete this. But we can also monitor the progress via the UV image editor in Blender. So I've opened up a new little window here and I'm in the image editor, and LiVi image is the one that we're creating. So we can see this is unprocessed and this is processed. Now it's white because we're simulating an outdoor scene here, and this is an HDR image which can contain much greater variations in brightness than my computer monitor can display, and it's whited out this image. We can sort of work around that. If I come down to back into my node editor, and I've now got this standard blended node tree called the compositor. What I can do, I just maximize that, is this LiVi image I can put into this node tree an input image node, which is this one. I can then select my LiVi image. I can then drag that image from that node into a tone map node, which is in the color menu. I can then modify this intensity number, and this will compress the high brightnesses in this image into a range that my monitor can display. And then that tone match image should go to my output composite node. And then if I turn on backdrop here, I will see that result of all these steps in this node in the backdrop of this node editor. So if I did my simulation again, so if I go back into my vSuite node tree, calculate the image again, then I should see, as that calculation progresses, I should see this image also update, because this LiVi image is being updated as the simulation runs. So it's going to take a few more seconds. I'm going to come back into my vSuite node tree here. And once this process is finished, this node should go gray. But I'm just going to add the second of the image nodes, a LiVi false color image. Now the LiVi false color image can apply a false color to this image that we've just generated. So if I take the image socket and connect it to this false color node, then I can now process this image with my unit that I'm choosing to relate to my colors. So because I didn't have a luminance turned on here, so in effect my image contains brightness, I want a brightness unit, which is candelas. I can set my color mapping, I can process that image, and then within the Blender image editor we should have had loaded up this fc-1.htr. FC for false color, which would change if we change this, -1, -1 for the current frame that we're working on. We're working on frame 1. So this can all be done parametrically as well. So if I open up that fc-1 HDR image, this is all whited out because my legend scale, my upper legend scale, is not enough in order to see the details in most of this scene. Most of the scene is too bright. So I'm just going to increase my upper level to 25,000, process that, and now I see I've got my false color image. And yeah, we can change the coloration of that. I quite liked thermal, I think. Yeah. So other options in this node will change the number of divisions. So we went from 8, we've now got 10. We can choose to either have the image, the legend on or off, although the legend still appears. Actually, that might be a bug which I'll fix in the next release. So it looks like the legend is always on. We can change the scale from linear to log, and that changes the color bandings according to the numerical divisions. Once we pick log, we can check how that log progression is done. Legend max, legend width, and legend height just determines the size of this. So because this is a 600 by 300 image, a legend of 200 by 100, it fits quite nicely with that image. I can also choose, instead of using a color fill, false coloration, I can create contours. So if I was to just process that, I've just got the contours now, the lines between the divisions of the different candela values. I can choose to overlay those contours over an image. Now I could select another image from a hard drive. If I leave it blank, it will be this image. So I can process that. That now appears over the image, but because this is an exterior scene and this image is whiting out again, I can also set the exposure. So 1, the exposure is the same. Multiples or more than 1 increases the exposure. Less than 1, between 0 and 1, decreases the exposure. If I process that, we can now see those color bandings appear on a more recognizable image visualization of the scene. And I can have bands which now they have a thickness depending on how much or how quickly illumination levels or luminance levels are changing within this image. So that's a handy way of doing false color visualizations of lux or daylight factor within a scene. We've also got the option now of doing a glare analysis with these LiVi nodes, LiVi image nodes. So my third image node is my LiVi glare image. Now I can take my image from there and put it into here, but I'm not going to process. What this does is it processes the image to assess whether there is visual discomfort within the scene. But this sort of glare analysis requires a fisheye image. So I need to turn on fisheye here. We want a field of view of 180. And I'm going to have a pretty low, again, a pretty low resolution just to keep it quick. And we want to make sure we have illuminance turned off. This is all about glare analysis, and visual discomfort is all about the brightness of the scene. So we want to make sure illuminance is turned off. So we're looking at luminance instead. So if I now process that image again, we should now see that we generate this fisheye of the scene. And because it's now a fisheye with a 180-degree field of view, it looks like we're much further away from the scene. When that finally finishes, now I can process the glare based within that fisheye image. So again, I can give the image that we're going to generate a name, a base name, but I'm just going to leave that blank. If I process the glare on that, then that will create a glare image. Now that glare image isn't stored automatically within Blender, but you can load it up within Blender. Now I've probably got it already loaded, and like the false color image FC-1, this is glare-1. All these images will be in the project directory. So my blend file is in HomeRine Work Blender, and the file is called LiVi Image. So in my Home Blender LiVi Image or Home Blender directory, I have my LiVi image.blend file in this folder, and I've therefore got a generated LiVi image folder here as well. In there, in images, you will see your basic LiVi image, your false color image, and your glare image, or whichever ones you generated for each frame that you're working on. So I've actually already got it loaded. I could just image, open image, navigate to that directory and open it up, but I've already got it in here. So I'll go into there and just make sure that that image is up to date. Now, so I've got this fisheye image of the whole scene, and this is processed to visualize glare, but there's no glare in this scene. We would see it because certain parts of this image would be colored. So sometimes you have to think about where or from what viewpoint a scene is likely to generate some glare, or at least I have to do that in this particular instance when I'm trying to demonstrate glare to you. So I'll move the camera now into this alleyway here. So it's a little bit darker in here, but it's bright out here. So if I now just regenerate that image based on this new camera position, then hopefully when I do a glare analysis of the image generated from here, we will see some examples of glare turn up. Now, while that's simulating, I will just mention that you could always do glare analysis within, if you selected it within the LiVi context node and did a LiVi simulation. And that option is still there for now, but this option is going to be removed in the next version, and all glare analysis will now be done based on this image workflow. So we're getting there. Sometimes particular viewpoints where there's lots of geometry in the way, or lots of light bounces are required from the camera to get to a light source, makes the simulation a little bit longer. So that image is now being created. Try doing a glare analysis of that image again. And if I now reload this image, yeah, we can see from the perspective of this camera, this would cause visual discomfort. This is very bright. We're in a relatively dark surroundings, but these bright surfaces would cause a visual discomfort to look at. So with this one over here, you can see different colors of the glare sources. That's because I've got random turned on in the glare analysis. If I turn on random, I can pick a color, whatever, and then all my glare sources should be highlighted. Reload that image in the same color. And we have glare probability, glare index, glare ratio, veiling glare, all up here in tabulated or listed metrics. So I think that might be everything I need to cover. So LiVi image, LiVi false color image, and LiVi glare analysis, all there to generate and manipulate radiance images. Okay, I think that's everything. Thanks for watching.